welcome all to Nadeep, your study buddy. We have started with the discussion on the topic linear programming in the previous lecture. We are going to proceed with the same topic today. Let us understand what is the application of LPP. So LPP, that is linear programming problem, is an optimization technique used in different fields such as planning, management, production, transportation. It is developed to optimize the utilization of limited resources to get the maximum result. LPP is used to minimize the cost of production and maximizing the profit. These LPP problems are related to the efficient use of limited resources like raw materials, manpower, availability of machine, and the cost of material, and so on. Now let us understand the structure of LPP. All the variables used in writing the structure of LPP are linear in nature. So as you can know, linear variable is 1 where the degree is 1, that is x raised to 1. It will not be appearing the variables like x square, x cube when you are writing the inequation or equation in the structure of LPP. So structure of LPP consists of decision variables. So decision variables are nothing but the variables which are involved in LPP writing the structure for the given problem. Objective function. A linear function of variable which is to be maximized or minimized. That is, we are going to optimize the objective function. The next is constraints. Constraints are nothing but the condition under which the objective function is to be optimized. And the last is non-negativity constraint. So value of decision variable, that is a variables when you are using to write the inequation or equation, these variables will not take the negative value, right? When you are producing something, when you are spending money on some materialistic different categories, it will not be negative. It will be either 0 or it will be positive. That is what is called the non-negativity criteria. Now let us look at the general structure of LPP. Suppose there are n different decision variables like x1, x2 up to xn, and z denote the objective function. So when we are defining the objective function, it involves the cost associated with each of the units manufactured for the variables x1, x2, x3. So that is when we are talking about a decision variable who decide, these variables are deciding how much or how many units of each of them should be utilized so that there should be a maximum profit or minimum cost involved in the given problem. So objective function z will always involve the cost contribution associated with each of the decision variable. That is why you see the objective function as z equals to c1 x1, c2 x2 and so on cn xn. So c1, c2, c3 these are the corresponding cost associated with the decision variables x1, x2 and xn. Now talking about the constraint parts, you may be limited with the machine hours or labor, and for that very reason what is the cost associated with the machine time or man hour, that is what you have to take into account when you are writing the constraint part. So that is why total amount will be given to you, how much time you can utilize for the man hour or the machine time, that may be specified in the given problem. So the total of this man hour will not exceed the total hour given in the problem. Similarly, for the machine, the total should not exceed the total of the machine time. And lastly, the non-negativity criteria, that is all the xi's, that is xj greater than or equal to 0, depicting that all the decision variable should be positive. So now as you have understood what is the structure of LPP, we can now formulate the given problem using LPP. So when you are formulating the LPP problem, these are the steps that you need to follow. First of all, read the problem carefully and identify how many decision variables you will be needing to express the constraint given in the problem. Secondly, identify what is the objective of the given problem. Are you talking about maximizing the profit, or this problem is about the cost involvement that we would like to minimize? So this is what is the objective that you have to clearly identify. And lastly, you need to write what is a non-negativity criteria. So now we have understood what are the steps involved in the formulation of LPP. Let us solve one problem. Let us formulate one problem using LPP now. A horticulturist wishes to mix two brands of fertilizers that will provide a minimum of 15 units of potash, 20 units of nitrate and 24 units of phosphate. 1 unit of brand 1 provides 3 units of potash and 1 unit of nitrate and 3 units of phosphate. 1 unit of brand 2 provides 1 unit of potash, 5 units of nitrate and 2 units of phosphate. 1 unit of brand 1 costs 120 and 1 unit of brand 2 costs 60 rupees. Formulate this problem as LPP to minimize the cost. So as you can see, we are manufacturing unit 1 and unit 2. So we would like to minimize the cost involved in the problem. So let us now solve this problem. As we are talking about preparing mixture 1 of brand 1 and brand 2. So let me assume there are two decision variables, X associated with the brand 1 and Y with the brand 2. So let us think that we are manufacturing X number of units for brand 1 and Y number of units for brand 2. So now as we are manufacturing number of units, X and Y, the decision variables should not be less than or equal to 0. It can be 0, but it can never be negative. So that is what is the non-negativity criteria. Now, here 1 unit of brand 1 costs rupees 120 and 1 unit of brand 2, it costs 60. That is what is given in the problem. So when we are talking about a total cost and we are denoting objective function by the variable z, so z will be equal to 120 into x because x are the units for the brand 1 we are talking about and y are the units for the brand 2 we are preparing. So it will be 60 into y. So total cost will be z equal to 120x plus 60y. Now because we are concerned in manufacturing, we are producing these brands. So we would like to reduce the cost as much as possible. So we would like to minimize it. So our objective of the given problem will be to minimize. So objective function will be minimize z equal to 120x plus 60 into y. Now, if we can just break down the information given in the problem in the form of table, it will be very easy for us to write the equation or inequation that depict the constraints for the given problem. So, we are talking about three different items, that is contents are potash, nitrate and phosphate. So, for the brand 1 unit, we have the potash as 3, nitrate as 1 unit and phosphate as 3. Similarly, for the brand 2, it is given as potash 1 unit, nitrate 5 unit and phosphate 2. And minimum quantity requirement is given as 50, 20 and 24 respectively for the potash, nitrate and phosphate. So once you have written everything in the table, it is observed that the brand 1 is utilizing 3 unit and brand 2 utilizing 1 unit of potash at a time, but the minimum requirement is 15. So we can write first in equation as 3x plus y greater than or equal to 15. So at least 15 should be there. It can be more than that also. Similarly, for the second constraint for nitrate, we can write x plus 5y greater than or equal to 20. As we know, the variable associated with the brand 1 is x. So we are multiplying. For the phosphate, it is 3 into x. For the brand 2, it is y. So 2 into y. And their total should be at least 24. So we can write the third inequation as 3x plus 2y greater than or equal to 24. So like we have discussed about the structure, we can frame it at a glance and we can rewrite the problem in the formulation of LPP will be maximize z equals to 120x plus 60y subject to the constraint 3x plus y greater than or equal to 15, x plus 5y equal greater than or equal to 20, x 3x plus 2y greater than or equal to 24 and x and y greater than or equal to 0. So this is how it is very easy to formulate the given problem using LPP. Only thing that we need to remember that we have to identify how many decision variables we'll be using. We have to think about what will be the constraint given in the particular problem and we have to just write what is a non-negativity criteria. So if you can write the information in the form of a table, it becomes very easy to formulate. Generally, this type of question they carries 3 to 4 marks in your board exam. So we will solve few more problems in the upcoming videos. So stay tuned. See you very soon. Thank you.